In this video, we'll take a look at an example of how to get an equation from a graph of secant or cosecant. So the original problem shows a graph and asks us for period, vertical stretch, and an equation for the function graphed above. So what we want to do first is take a look and see whether that more closely matches secant or cosecant. So if you take a look at our notes for section 8.2, let me open those. The graph of the secant function starts and centers around the y-axis. The graph of the cosecant function starts at 0, and the first period goes between 0 and pi. So this graph, since it starts around, is even basically, and starts as the y, half of on one side of y, half on the other side of y, we're going to go ahead and use the secant. So the general note, features of the graph of the secant, y is equal to a times the secant, a is the vertical stretch, times bx minus c, b is the period, and then c would be a horizontal shift right or left, and d would be vertical shift up or down. So the graph that we're looking at is only using the stretching factor and the period. So let's take a look at what we've got and try to figure out each one of those. So notice the original graph for the stretching factor, it has minimum values at 1 and maximum values here at -1. So those are the key points for your stretching factor. Take a look and see where those two values, where they are on the graph. So this particular graph, notice it is the secant function, but it's upside down. So we're going to use a negative secant, just a little note to myself off of the side. This is going to be a negative secant because it's reflected. And notice where the maximum values are. They're -2 and +2. So the vertical stretch for the graph is equal to 2. Then the period for the graph shown above, notice that the secant function does this and this in one complete period. It's hard to see where the vertical asymptotes are, so use where your values actually touch an integer part. So right here we have 0, and then again it occurs at 3, and then again at 6. So the distance between these two is 3. So the period for the graph shown above is going to be 3. So we want our equation to be y is equal to, it'll be -a times the secant of bx. So if the period is equal to 3, then the period, just like the sine and cosine function, is 2 pi divided by b. Our period is 3, so we get 2 pi divided by b is equal to 3. Multiply both sides by b, and then divide by 3. So we get b is equal to 2 pi over 3. So the equation for our function is, use y here, is y is equal to negative, because it's a reflection, 2, because that's the vertical stretch, times the secant of 2 pi over 3 times x.